part C of the problem asks for the parts of the concavity, so the parts where a of x is concave up and parts where a of x is concave down. And a of x is concave up when a double prime is greater than 0, and a of x is concave down when a double prime is less than 0. So I found the second derivative of a of x, and then from there I found where the second derivative did not exist, and the second derivative does not exist when x is less than or equal to -3. And then a double prime of x, the second derivative, is never equal to 0, because the only point where it could be equal to 0 is where the part in parentheses 1 minus 1/4 x over x plus 3 is equal to 0, and that would be at x equals -4, but the second derivative does not exist at -4, so the second derivative is never equal to 0. So then I made a number line of a double prime of x, and then from that I could see the intervals where a of x is concave up or concave down, and since a double prime is never less than 0, a of x is never concave down, and since the second derivative is always greater than 0 except for where it does not exist, the interval where a of x is concave up is from -3 to infinity. And then part D just asks you to graph the function, so there is my graph of the function.